It does relate to geometry.
Yeah, I remember this was part of the course last year. Well, it was going to be part of the course.
Yeah.
So,
And you guys are going to be taking geometry next. So it's important that you get a good, strong understanding of exponents so that you're ready for geometry.
I just have one question. I'm still kind of doing the pre-assessment, and on one of the problems, I have my answer, but I can't find the answer anywhere.
Don't spend too much time on it. Just mark, either take a guess with the answer shown or mark, I don't know. Maybe one of the answers is close to yours.
Okay, are you going to show us what the answers were afterwards?
No, but we are going to learn how to do some of them right now.
Okay.
So whatever number is here in with exponents, this is what we call a base. The base is whatever number you're going to raise to the power. Like in the example, I had 10 as a base. It's not, you can use a variable if you want. You can call it A, B, C, whatever. Or you could actually put a number in there. This part up here, this is what's actually called the exponent. So that's what we're focusing on now, is how do we handle those. And when you have all of those together, this whole thing is what we refer to as a power. So some vocabulary there that you need to be familiar with. And let me know if you have any questions as we're going along, okay?
I have one question.
Yeah.
I don't want to give any spoilers in case it's not, but are we going to be covering the principles of exponents, including like division and multiplication, and negative exponents?
Yep.
Okay.
Today we're actually going to focus on some negative exponents.
Okay.
Yep.
Thank you. Thank you.
You're welcome. This is a really exciting lesson. There's a lot of really cool things that happen with exponents, and there's lots of patterns that we can watch out for. All right, so someone give me a number that we can use as a base.
7.
7. Thank you. Someone give me a number we can use as an exponent.
3.
And I saw Shrita's first. I saw it too. So then what would our power be?
Our power would be 2 because exponent. Oh, the whole thing, yes.
Yeah, sorry. You know what? I could call this a base. Maybe that'd be better. So here's my base, and the same as the number 7. The exponent's a 2. So the power would be 7 to the power of 2, but we can simplify that. Remember, that means 7 times 7, right? So that would simplify to 49, or 7 squared, yep. Someone else, give me a variable. X. Okay, cool. Someone give me a power. Ooh, Shwarya, 7. Oh, wait, I said power, but I should have said exponent. See, the vocabulary is tricky. So our exponent 7, our base is x. So what would our power be? X to the power of 7. Ishan A, yes.
This year in math, are we ever going to cover numbers with exponents that are variables, like 7 to the power of x?
Okay, let's do it right now. 7. Exponent is an x. What would our power be?
7 to the power of x.
And there's a lot more we can do with that too. We will see those sometimes.
No, I was wondering if are we going to figure out how to solve these?
We're working on it. We're getting there. I'm trying to build your vocabulary and the background knowledge right now because we're all in different spots. So these are all things we might see, right? We might see these kinds of powers. Here's another one. What if our base had actually a couple of things in it? What if it was x plus 2? And let's say we had an exponent that was 3.
So it would be x plus 2 in parentheses to the power.
Good, you guys remembered the parentheses, yep. So see, all of these are examples of exponents. Originally, when you first learn them, you only learn like, how do I cover it up like that? You only learn kind of like those. right? Now in algebra, we're going to be talking about all of these, and there's even more. So now this I could simplify because I know what 7 to the power of 7 times 7 is. This one, I don't know what x is yet, so I can't simplify it anymore. This one, I don't know what my exponent is, so again, I can't simplify it anymore. And then this one, these are kind of special, and we'll spend more time on those in a different unit. But right now, the only one we can really simplify is this first one. Sriyanshi, if you go to the y equals, I see your question. If you go to the y equals and press clear, it should get rid of it. Yeah, so right now, this is as far as we can take these, but in our lesson, we're going to be looking at some others as well, other ways we can handle them, okay? Okay, I want to review. Ishan, is your hand up or was that from before?
It's from before.
Okay. I'm going to share some of my slides with you guys here, and you don't need to copy it down maybe unless it looks new to you, but I just want to remind you of some stuff here. Sriyanshi, we can work on it more a little bit later. Ishan, yeah, a lot of questions today, yeah.
I just want to say that I'm not going to be taking any notes. I made a document about everything covering
Okay, cool.
geometry.
So,
am I allowed to reference to that in tests where we are allowed to look at our notes? Because
sure, that's fine.
Okay.
Okay, so guys, remember, this is what happens when we have exponents, right? Sometimes students think like 2 to the power of 3 means 2 times 3, or 2 to the power of 4 means 2 times 4, but really it doesn't, right? Exponents is repeated multiplication. Hopefully that's review. You've seen that before, right? Okay, now remember, I told you, exponents is all about patterns. So be watching for some patterns. Let's see what happens if we had a negative base. So same kind of thing, the base changed, but we're still going to the power of, or to the exponent of 1, an exponent of 2, an exponent of 3. What do you notice though?
If the exponent is an odd number, then the base is a negative number, then the result is going to be negative. But if this situation is the same except the power is an even number, then the answer would be an even number.
And yeah, it's the same pattern.
Wait, not an even number, positive number, yeah.
Positive. That's the same pattern I saw as well, and you can see it there in the colors. Does anyone see any other patterns? And this pattern makes sense to us because if you think about it, right? If you're multiplying negatives, well, if you have a negative times a negative, you get a positive. But if you have a positive times a negative, it makes a negative. So the answer like flip-flops between negative and positive. And it makes sense why, right? Because the base is negative. So you might see some like that. It's all means the same thing, the repeated multiplication. Okay. And variables would work the same way. So now we're getting into something might be a little bit new, is maybe we don't know what the base is. Well, we could still write it out. This is called like in long form, where if you had a to the power of 4, well, it still means a times a times a times a. And if you had a negative b, it's still the same thing. But remember, you can start to predict if your answer is going to be negative or positive. And if you forget that, you could just try putting in a number. That's one way mathematicians can help if they get stuck on a problem with a variable, is you can just pick a number and see if you can find like kind of a prediction or a pattern in that. Are there any questions about that? So right here, I want you to see that if the base is negative, then sometimes the answer is positive, sometimes it's negative. That's the big point of this, what we're talking about right now. Okay. You're going to try a couple problems. You have a choice. I would like you to either do the problems in column A or the problems in column B. Look at them right now. You decide whichever one you feel more comfortable with, and then copy it down on your paper and solve. I'm going to give you a couple of minutes for this. If you want, you can use your calculator, but you might be able to do it without. It just depends. So right now, go ahead and try these two problems, and then we'll check the answers here in a couple minutes, okay? If you like, you could do all 4 problems. You don't have to. Either do column A or do column B. Ishan, is your hand up again, or is that from before?
It's from before. I keep forgetting to lower it.
It's all right.
Can we do column A and column?
Mm-hmm.
Okay, I finished.
Okay, make sure you have answers for the problems.
Yeah, I did that.
Cool. So what we're doing right now is called simplifying. I gave you a problem with exponents. I gave you powers. And what you're doing is you're actually doing the multiplication and getting to an answer. So sometimes with simplifying, it's like solving. You get to an actual answer, and that's what these are. And and there's a little bit of stuff going on here, right? Like we have those negative bases that we talked about. There's a decimal in there. There's fractions. So maybe you have to remember how to multiply fractions. What do we think? Maybe like 30 more seconds, and then I'll show you the answers.
Can you please wait for a second?
Sure. And if you guys need more time, let me know. I'm going to give you a little bit more time right now, but I'll warn you before I show you the answers. I know some of them are a little bit longer. You might not be done, but let me show you, and you can correct what you have so far, and we'll talk about how to do it. If you're not at your answer, you can still figure out if you're doing it the right way or not. Sound good? You guys ready? Okay, oops. Sorry, that last problem changed. Wait, what happened there? That was weird. Huh, okay, well, you can have an answer in fraction or decimal. So notice that you just have repeated multiplication. When you have fractions like 4/5 to the power of 2 with the exponent of 2, that's 4/5 times 4/5 times 2/3 times 2/3. So sometimes it's helpful to take it one step at a time. I don't know why that second problem on column A changed. That was kind of weird. Or on column B, you'd have 1/2 times 1/2 times 1/2 times 1/3 times 1/3. So that would be either 1/72, or it's 0.138, and I think the 8's repeating.
For column A, problem 1, shouldn't the answer be positive?
Ooh, I think you found a mistake. What do we think? Do you all agree or do you disagree?
Well, I didn't really do column A, but just by looking at it, I think it should be positive.
Yeah, because I got the same answer, but positive.
Good catch. Yes, it should be positive. And Gagana, I see your question. Are you talking about column A or column B?
Column A, but it's fine. Like, I was also confused about the same thing.
Yeah, because it also, the problem A, the second problem, didn't it change? Because like, wasn't there 3 fractions? Like if you go back, see?
Yeah, that was weird. I don't know why that happened.
So which one should we solve?
This one, because I have an answer to this one. I don't have the answer to the other one. Sorry about that.
Okay.
I like that up here at the top, the 798, that should be a positive. And over here in column B, you can see we have all positive numbers, and yeah. So exponents are just repeated multiplication. If you have the negative inside as a base, you have to be careful with how it works. And with fractions, it still works the same way, repeated multiplication. Now we're going to get into something a little bit different. We're going to talk about, well, what happens if the exponent's 0? So again, watching for patterns. We have some ideas in chat already. So we already know that there's this pattern. If we reverse engineer it, if we kind of like work backwards, you can think of it like this, where it's kind of like we're dividing by 2 every time. So the question is, what happens when we get to an exponent of 0? You guys are saying it's 1.
I learned it a different way. I thought that every time it's 1 into like 2, if the thing was 2 to the power of 2, then it would be 1 into 2 into 2.
1 into 2. Oh, I hadn't thought about it like that.
That's how I learned it too.
Like each one in front of it, it would be 1 into 2 into 2.
So that could be a useful way to remember it as well. If we continue this pattern here, then when we divide our answer by 2, we get 1, which would be 2 to the power of 0. So there's kind of 2 different ways you can think about it then. Sounds like it's the way some of you have learned it before, or there's this way as well. If you just reverse engineer what we already know, then we can see if we work backwards in the pattern, we go 2 divided by 2 and we get 1. Okay, so let's put this in our notes then. I'll show you what I want, what it should look like. So what we could say is, we could say if we had 2 to the power of 0, we said that's going to be 1. Or if we went back to like these examples up here, if we had 7 to the power of with an exponent of 0, that's going to be 1. If our base was x and our exponent was 0, it's still going to be 1.
It would still be 1 if the base was negative, right?
Yeah, -5 with an exponent of 0 is going to be 1. One thing we like to do is we like to put that in parentheses just so that we know that that whole thing is our base. I haven't shown you how to do these ones yet, but I think you already know the answer. Do you know what this is going to be simplified to?
Is that x plus 2 or is it x
Plus 2. It's an
times
x 2. It's a plus. And even though that there's like this like math going on in here, because it's to the power of 0, it's going to be 1. Isn't that pattern nice? Look at that. 1s, right? Okay. I'm going to give you guys a couple problems to try again. And I'm just checking real quickly to make sure they don't change on us. I don't think they're going to change on us. I really hope not. Well, actually, I do see one thing I need to fix real quick. All right, hold on one sec. Let me change something. I want to let you guys try this out, but I want to make sure that the problems are good and ready to go. Okay, I think we're good now. So let's see if you got it. Let me see if you can use now what you know to solve a problem. So same as before, you can choose column A or column B, or do both. And the directions on these often say simplify. It means if you can, get to an answer. If you can't, then just simplify as much as you can in that problem. So there's 2 problems in column A, 2 in column B. Go ahead and try them out, see if you can simplify, and then we'll take a look at the answers here in a couple minutes. My advice to you is just take it one step at a time. There's a lot of bases now and a lot of exponents, so a lot of powers. So just do one power at a time, and then deal with whatever you get as you start to simplify. Thanks, Dougie. Thanks, Mrs. Flood. All right, about 1 more minute, and we'll compare what we have. We'll correct whatever we can. All right, we're going to take a look at the answers. I don't think the problems are going to change on us. They should stay the same. Here are your solutions. So the first one is 36 in both of them. And like Dougie pointed out and Mrs. Flood, if you have something to the power of 1, it's just going to say that number. So 4 to the power of 1 is just 4.
It changed.
Let's see.
There was a parentheses on the H.
You are right. Ah, shoot. You know what? Let's fix that right now. It was 6h squared, so this was 6h squared. That means the answer should be 6h
Oh, okay.
to the power of 2. Second period, you get to see all the corrections today.
If anyone's trying to type superscripts quickly, if you hit Control and the period button, at least on not on Apple's maybe, but on other computers, that'll get you to a superscript quickly. So control and period, if you're trying to type exponents, is the way to go.
I didn't get the for column A, the second one.
Me
Yeah.
too.
I got 36h squared divided by 4g.
Yeah, so let's talk about that one for a little bit.
I just forgot the h squared, so that was my.
Do we have to simplify our answer every time?
Yes.
Okay.
So some things to point out there. The base is 36g, but it's to the power of 0. That means that whole thing just becomes 1. So the g is actually gone on the top, and the 36 is gone. The 6 doesn't have an exponent. The h does, though, so we get h to the power of 2. And so on the top, we end up with 6 times h squared, and on the bottom, we have 4 times g. But then we have to simplify because 6 over 4, that's just a fraction, that's 3 over 2. So 3h squared on the top and 2g on the, and 2g on the bottom. Or if you did column B, the top simplified.
How do we get 2g on the bottom?
Because we had a 6 on the top and a 4 on the bottom.
Oh,
Yeah,
so we
we
just
simplified
divided
them.
by 2? We
Mhm.
simplified. Oh, so
Six-
we
Yeah,
can
we
just simplify this like fractions. Like we can just reduce it in half and it'll be the same.
Yep, it's 6/4. It's 6/4 times h2 over g. So it's just like a fraction, you just simplify it.
Okay.
Mhm.
Will you hold that a little bit longer so we can write it?
So notice if the zero's in the exponent and your base has like a bunch of things in it, well, that whole base becomes 1. The whole thing simplifies to 1. It doesn't matter what's in the base. To the power of 0 is going to be 1. Yep, I'd agree with you, Ishan. And it all comes from that pattern, right? It's because if you did the exponents in reverse, then you're dividing it by itself every time, and you're getting smaller and smaller. And so when you get to the end, well, then when you get to the power of 0, it's just 1. Yep. Okay, we're going to go on. So we've talked about positive exponents. We've talked about negative bases. We've talked about 0 exponents. What we haven't talked about are
Negative